Good afternoon. Thank you all for finding time and visiting today's webinar. My name is Zuzana Tatyakova and I'm a project manager at Phoenix TNT. This webinar is organized with support of BUP. It's the European portal for energy efficiency in buildings. It is the largest international portal to discuss, contribute and collaborate with other experts in this field, and we are happy to collaborate with them on another webinar. The recording of this webinar will be available at their website, and you can also find more information there. Our topic today is lightweight solutions for high insulating building envelopes developed within the EENSULATE project. You will hear three presenters who are working on the project. And these are Daniela Ricardo, Alessandro Pacucci, and Anna Bogac. If you have any questions for the presenters, please send them to us through the chat. We will have a Q&A session at the end to answer your questions. Let's begin. Our first speaker is Daniela Ricardo, civil engineer specialized in structural engineering and energy efficiency in buildings, with expertise in building energy performance evaluation at RINA Consulting. She's the project coordinator, and she will introduce the project. Daniela, the floor is yours.
Thank you, Susanna. Good morning to all of you, and thank you for the introduction. Okay, today I'm going to present to you an overall general presentation of the EENSULATE project, and then I will leave the floor to the other partners who will present you more in detail what we have developed with this very interesting and challenging project. The project started in August 2016, and the overall duration is 58 months. So it is planned to end by the end of May 2021. It was a very long period because the project has been seriously affected by the coronavirus pandemic, and for this reason we had two extensions of the project duration during the project life. The target of the project is for existing building as well as for new construction. Thanks to the three key enabling technologies, we develop different products with the support of 13 partners all around Europe for a total amount of budget of 6.6 million. The main challenge of the EENSULATE project consists to the fact that thousands of buildings in Europe have been constructed recently using the curtain wall technology, and many of these buildings are now 30 to 50 years old or even more. Therefore, the curtain wall technology, in addition, is moving from office building to the residential tower within the urban context. And for this reason, windows and glass facade are estimated to be responsible of around 60% of the energy losses through the envelope. Therefore, the replacement and the retrofitting of curtain walls would allow a significant enhancement in thermal performances, as well as also a decrease of this discomfort for the occupants. This is a view of the curtain wall module that we developed in EENSULATE project, where the thermal and the acoustic insulation are provided by the EENSULATE glass based on the VIG technology and on the EENSULATE foam in the expander part. The EENSULATE model allows to achieve thermal and mechanical performances according to the technical and standard requirements, as well as the market drivers. Now I'm going to go a little bit more in detail concerning the technologies that we develop for producing the EENSULATE products. In particular, the vacuum insulated glass is a lightweight and thin double pane assembled thanks to the innovative sealant and getter technologies, for the transparent part of the facade, as well as for the windows application. In addition, for the spandrel part, we develop an highly insulated foam based on monocomponent and bicomponent elements. Concerning the VAG, the vacuum insulated glasses have been developed by Vigitech, who is a company based in Poland, of course with the support of the rest of the consortium. Vigitech developed a tailored manufacturing process implementing both the innovative sealant and getter strips to ensure the target performances for the final product. That is a target of a new value of around 0.36, 0.44 watt per square meter Kelvin. During this project, we developed several small-scale big prototypes of 500 millimeters and also large-scale prototypes. Currently, Vigitech is assembling the latest real-scale VAG for the pilot's application. Regarding the foam, the monocomponent foam is specifically for Windows application and has the characteristic of a very high insulating target. And the two-component foam has a high fire class and it is tailored for spandrel application. And both of them have been developed by Selena, a partner of Insulate project, and it is a Polish company. The innovative foams are based on polyurethane foams with tailored cell morphology, size and structure in order to enhance the thermal performances through the precise control of the cell's nucleation. Concerning the sealant, it is the sealant used for the assembly of the VAG system is an epoxy resin sealant, and the thermal curing allows a low process at a temperature below 200 degrees. We also have the possibility of having a monocomponent sealant resin in a syringe form, dispensable in a range of 60 to 100 degrees. The sealant has been developed from SAES, who is an Italian company. This sealant has a very high performances in terms of permeability, because it is an extremely high barrier performance for argon, nitrogen, and oxygen. It is necessary to store it in freezer at very low temperature, but the processing can be performed in air. Regarding the getter, it is a distributed getter realized with innovative zirconium-based alloy with extremely high nitrogen capacity. It is very easy to be handled and positioned in air during the production process of the VAG. The getter activation is performed by radio frequency heating under vacuum pumping. Within EENSULATE project, we have 3 different pilots demonstration all around Europe. 2 of them are based in Poland and 1 of them in the south of Italy. Going a little bit more in detail, we have a school in Dzierżoniów, Poland, where we already are working for substituting all the facade that you can see in the picture. In this particular pilot, we will apply not only the VAG technology that we developed in Insulate project, but also the TGU, traditional triple glazing units, in order to compare the current state of the art with respect to the innovative solution through a monitoring. Concerning the museum, it is the second Polish pilot, based again in Dzierżoniów. It is an ancient building, and it is also under it is an historical building, and for this reason we could not change all the windows, but we simply remove them and include into the same frame the innovative VIG system. This is possible simply because the VIG is lightweight that we are developing and very flexible for the application in different kind of configuration. Last but not least, we have the pilot placed in Pesaro, the south of Italy. It is a public library, and we will substitute the glasses within the door window that you can see in the bottom part of this slide. In this way, we are able to test and to validate the solution that we are developing in different countries around Europe, covering different climates. Regarding the impacts of Insulate project, we developed a products that meets the market demand and targets and are affordable and applicable for the retrofitting of the building as well as for new buildings. We have around 20% of improvement in terms of durability, 15% in terms of reduction of energy, 20% regarding the costs, because they are very easy to be handled, and also the 25% of improvement in terms of insulation. This is an overview of the Insulate consortium. We have partners all around Europe cooperating for achieving the results that we and the products, developing the products that we are I just presented to you right now, and I think that's all from my side. Thank you for your kind attention. These are my contacts. Please feel free to contact me for any further information or question that you may have apart from the Q&A session that we will have afterwards. Thank you.
Thank you very much, Daniela, for your presentation. Now we have a question for our audience. We will set out a poll, and the poll will be question to you: are you aware of the vacuum insulated glass VIG technology developed in the project and its potential in terms of performance? Our options are yes, not in detail, and no. Please vote now. We will wait for the results. Let's have a look. Okay, so 63% voted yes, 33% not in detail, and just 4% no. We are very happy that we have audience which is interested and aware of the technology. And if you want to learn more and more details, feel free to follow up with the project social media, the website, and contact the speakers if you want to talk to them directly. Let's move on. Our next speaker is Alessandro Bracucci, a project manager and member of the innovation committee at FOCI. He is responsible for corporate innovation activities in the company aimed at investigating new technologies and new business opportunities. Alessandro will speak on the EENSULATE facade module integration. Alessandro, the floor is yours.
Thank you, Fulana. Thank you for the presentation. Here what is the insulated facade module integration. Just a more outline about the activities we conduct. Here's the outline of the presentation. First of all, the insulate technologies. As more recap, just to say the technology we're going to integrate with some achievements of the project, and then how these technologies can be integrated in the insulated facade module with a focus on the facade system design, its prototype, and the testing phase. And finally, the conclusion of the achievements within the project. Two technologies are the crucial for the insulate facade module. First of all, the foam. This is a pure foam that is should be applied inside the spandrel, so the opaque part of the facade, with the idea to replace the cut-to-measure mirror wool insulation that is usually used in curtain wall facade. So this represented a first challenge for the project to include this type of foam inside the spandrel. The results are interesting, and it opens some opportunities for its wider application in industrial scenario, and some further development obviously are needed, like normal in innovative product, but it's very good achievement. The second product, second technology is the vacuum insulated glass. As Daniela has already mentioned, it's quite innovative for the product is manufactured with. In particular, the sealant that can guarantee that the coating of the glass will not be damaged during the activation of the curing of the sealant. And second, the getter, the strip responsible to absorb the air that eventually goes inside the cavity, and it achieved very good results as we are seeing in the test we are conducting in this very moment. What are the final results of the VAG useful for the facade? First of all, is 2 times better than a commercial sealant for insulated glasses. It represents a very valuable moisture barrier for the glass itself, and allowed to use also coating for glass thanks for the low processing temperature. One of the main issues is how to cure this sealant, preserving the coatings that now are used for glass, and thanks to this sealant we achieve also the result. The getter on the other side allow for a very relevant improvement in relation to other getter on the market, achieving very high performance for the VAG in comparison to other VAG competitors of this insulate VAG, but also as well as one of the benchmark this very moment for the market, that is a triple glazed unit. And second and third point, we demonstrate how this also glass could be laminated so to preserve also safety reasons for its application. How we integrate this solution? This was the target we wanted to achieve within the project. So achieve a new value for the wall module of 0.7. It was an achievement we designed specifically using one of the demo buildings that we expect to renovate during the project. And as you can see, this is a unit of 1.2 meters for 3.6, and the overall target is quite relevant in relation to the current benchmark. What we've done, we have implemented during the whole project the integration of VAG, try to figure out the best solution to improve the facade design to integrate this component. In particular, one of the main issues was related to the VAG. So the VAG has wanted to achieve the target of 0.3 watt on square meter Kelvin for transmittance, and the foam 0.02 of watt on square meter Kelvin. The integration of VAG was something that addressed strongly the design of the profile for the facade. First of all, because the sealant represents a thermal bridge for the vacuum insulated glass, and so we try to figure out what could be the design could better achieve the result we expected for the module. And the final configuration, here you can see the implementation during the different design phase, allow to have this type of solution. So we finally add a sealant with 25 millimeters of thermal bridge. The getter is not relevant for thermal bridge because does not create any continuity between the two glass panes. We design a curved profile to work with the isotherm we have for the thermic of the thermal performance of the facade, and this curved profile work in the same way, and we fill this curved profile with an EPS foam materials just to help the reduction of thermal bridge, with an U value for the node of 3.1 watt on square meter Kelvin. The result is very relevant and perfectly in line with expected target. So the U value for the whole module for this vision part of the module was 0.64 watt square meter Kelvin. Same considerations was adopted for the expander part, where we adopted the foam. So the foam guarantee a very high performance in relation to the mineral wool because the conductivity is better, and so this contribute for the achievement of the target of the module. We design specifically, obviously as typical on carton wall facade, the details of the facade, figuring out how everything fits perfect in the final configuration for the facade, and finally we achieve the configuration of the facade itself. Here you can see the achievement specifically designed by Foki within the project. So you can see not only the profile, but also the technical solution we figure out to reduce the thermal bridge. In particular, you can see a thermal break in polyamide that is quite relevant because it absorbs all the thermal bridge caused by the sealant. And we apply, in this case, mechanical restraint for the vacuum insulated glass, due to the fact that we wanted to adopt something without utilization of structural silicon. But the same facade system solution was also designed for structural silicon, so expecting to meet one of the main target of current architectural design, try to decrease the mechanical restraint presence in the outside of the building. Here's a comparison. On the left, you can see the EENSULATE facade module with the main component. So the vacuum insulated glass with the transmittance that is a target. We are perfectly in line. I can anticipate it. It's not part of this webinar, but the test demonstrated that we are in line with this target. Then the U value for the node and the unit. We can the transmittance for the unit. Compare with the benchmark on the market. If we design something with a similar profile for the market, we would use for the triple glazed unit and mineral wool. And as you can see, it's an improvement of the overall performance of the facade itself. The prototype phase, we prototype everything for the testing activities. So here you can find some aspect of the manufacturing. In particular, we tested how to pour the foam inside the expander. So a preheat was needed because being a foam needed 50 degrees of temperature before the pouring. So all the procedures were tested and applied in the mock-up manufactured in our facility. Here the final result, as you can see, it's a good result that could support the consequent glazing of the expander part without any particular issue. Then for the vision part, here are some details about the curve profile and the foam inside the profile itself, and the glazing with VAG. As you can see, it can be managed easily using a suction cup without affecting the VAG itself, and then the unit closing with the mechanical restraint, and the final prototype ready to be tested for the different testing activities. What are the tests we are now conducted? In these weeks, we expect to finalize 3 types of tests. The first is performance mockup. So in a test chamber in accredited entity premises, the test conducted by this entity will test in line with the norm, the 13830, the facade, to obtain the CE certification, and in particular in this test we'll validate everything around the facade. So first of all, the VAG performance in the vision part, but also in the vent we have installed, but as well also we want to know if the system work for, in the case of benchmarks, so to use as a comparison to effectivity, what are the differences, if there are. The second test is the acoustic mockup. In this case, some preliminary tests have been conducted in the past years to validate the foam, and we introduced an additional plasterboard to meet the needed insulation of the spandrel. We test in an acoustic chamber here in our facility with the target to achieve the 52 decibel of insulation, in line with the in-out test issued by the norm. Final but not least test is the fire mockup. The fire mockup will allow us to compare the benchmark on the market, so unit with TGU and mineral wool with the insulate module, so with VAG and foam, and to see effectively how they work, if they work differently, and what are the main differences. Will not use the traditional temperature increase curve by the 13501 norm for the reasons behind glass sealant facade and so on, but we work on slow rate temperature increase just to know effectivity, how it can work and see differences at different temperature. Some conclusion about the project. The insulating technologies demonstrate that can be integrated in a unit edge facade, achieving a very high energy standard for the building envelope, with them working to decrease the overall energy performance of the building, and also, indeed, it's quite particularly relevant, the reduction of facade weight, so means less glass, less materials, less energy in the body component of the facade itself. The next step, the testing activities. So we aim to achieve the CE certification of facade and to validate the acoustic installation of the facade. There are some minor aesthetic issues to be managed, but there's something that the team is working on. That's all from my side, and thank you.
Thank you very much, Alessandro, for your presentation of the technologies. Let's get another poll going regarding the technologies. So the question we have is, do you think that the project technologies, VIG, foam, and the facade panel could be interesting for the building sector in your country? Please vote now. Let's have a look at the results. So the results are in. 81% voted yes. We are very happy with this result. 4% voted no, and 15% not at the moment. Of course, we are still working on the technologies and they are being developed. So, of course, there is some room for improvement and for the implementation, but thank you very much for sharing your interest in your country. Let's move on to the final speaker, who is Anna Pogacz. She has expertise in the design of advanced windows and facade systems integrated in prefabricated structures and curtain walls, and works at Bergamo Technologies. Anna will present the EENSULATE real scale demonstration, and then we will show you a short video. Anna, the floor is yours.
Thank you. And good afternoon. I represent BGTech. Within the project, we are mostly responsible for vacuum insulated glass manufacturing and installation activities. And therefore, next presentation is focusing on implementation of EENSULATE solutions on demonstration buildings. And I will go through the overall concept, installation approach, and actual status of particular demo case, finishing by system advantages from installation point of view, and short movie from installation process. And the next slide, please. Three EENSULATE solutions has been applied on the real buildings, which are EENSULATE foam suitable for two types of applications. One component foam for insulating gap around the window, and biocomponent foam to fill the spandrel volume in facade units. Then EENSULATE vacuum glazing for new, existing, and historical windows. Both EENSULATE foam as well as VIX can be integrated in a facade module with customized profiles. Next slide, please. Retrofitting scenarios were defined in order to demonstrate the wide applicability of EENSULATE components in different building retrofitting case, and it can be applied for curtain wall facade. In this case, EENSULATE module is used for the replacement of existing facades as a lightweight solution to reduce the weight of the structure and to increase its thermal performance. And the EENSULATE vacuum glass for substitution of the standard triple or double glazing units in existing facade. In case of a new facade, after preparation of prefabricated models in the factory, installation steps on site, including standard procedures like dismounting of existing facade, preparation of the surface, installation of supporting system, then units settling, taking into consideration all connections, sealing, and finishing. Next slide, please. And the second type of application, EENSULATE VIC for replacement of all single and standard double or triple glazing in existing windows for historical and contemporary windows and doors, with improvement of performance without affecting the overall view. Works are restricted to substitution of existing glazing for vacuum ones only by window sash dismounting. It's a renovation and vacuum glass insertion, and if necessary, renovation of the frame, then window assembly and sealing. And to facilitate and accelerate installation process, application guidelines were developed within the project before planned intervention. Next slide, please. Oh, sorry. And different project demo buildings have been selected to demonstrate EENSULATE products, adaptability, in different retrofitting building cases. Solutions developed within the project and presented before has been installed on 3 demonstration buildings representing different types. A school in Poland where insulate facade modules with triple glazing and vacuum glass has been installed. Then museum and library where existing glazing is substituted with vacuum insulated glass. A first demonstration building with biggest scope of intervention is a primary school in Dzierżoniów in Poland, where a glazed facade of area around 150 square meters were dismounted and the new insulate one installed. The building has been constructed in 80s with a total curtain wall facade surface of around 500 square meters, and the scope of insulate intervention covers one of 3 facades. Due to this reason, a specific request of the municipality was to preserve aesthetic homogeneity of the retrofitted facade in regards of shape, divisions, and color in relation to the existing ones, not objected by the intervention, and to be compliant with 2 other facades. And installation works are completed, although some finishing activities are still pending and will be continued soon. Unfortunately, due to a current situation, some processes are more difficult and time-consuming, also due to the restriction in traveling. As in case of standard installation, preparatory work is foreseen building investigation and measurements, designing or necessary details and connection with existing building, 3D drawings reflecting scope of the future intervention, and also structural calculation of the new structure and assessment of connection methods between particular elements, and all taking into consideration requirements of the building and its responsibilities. So activities were preceded by preparatory works like taking measurements of existing facade, then on the basis of detailed drawings, section and connections, modules were manufactured, and then all necessary elements prepared in the factory to conduct works on site later on. The first action was dismounting of existing aluminium facade as shown on the photo. And then installation process of insulate facade system were similar to installation procedure used for traditional facade retrofitting. The main steps were site preparation and fixing of supporting elements for facade models installation, and proper anchors positioning located on the floor front of the floor slabs is crucial for undisturbed unit mounting. And next step is to settle the facade models into position marked on the drawings and secure them to the building. And in this case, the works were conducted from outside. Units were lifted by means of crane from the storage place on the ground near to the building, and directed by the staff to be installed to anchors fixed on the slabs. And installation proceed with direction from left to the right and from bottom to the top. Additional components like gaskets, sealing, and joints should be properly applied for preserving permeability of the facade wall. And on the slides, particular steps from installation are presented. And new facade after intervention, and it can be noticed comparing pictures before and after installation that the shape, divisions, and facade colors are almost the same. And the second demo is a historical city museum building from 1897. And today the museum hosts exhibitions concerning city and surrounding area. And being a historical building, a museum has its restrictions in regards with modification of elements of its construction. And it was requested that for the new windows appearance is exactly the same like existing ones. So thanks to the insulated vacuum glass, it's possible to substitute the existing poor performing old glass with better performing glazing, keeping the same construction of the windows, and thanks to the thickness and light well construction of new glass. In case of replacing the new windows, it is usually very challenging to obtain the same details of all construction as shape and hardware. And with our solution, this process is easier and it's possible to facilitate the procedure of obtaining special permissions. So in case of Polish Museum, the scope of activities within EENSULATE project foresees a substitution of old single glass with EENSULATE wick of thickness 10 millimeters and weight 25 kilograms per square meters. And existing windows are old box windows with double sash opening to the inside, filled with a single glass. Here photos presenting inside and outside view. And window sash has been carefully removed in order to perform necessary renovation works, and then a single glass will be replaced by wicks, and the same element will be installed into existing frame. Works are still ongoing, and the sash is uninstalled, currently under renovation in company facility. Vacuum glass fabrication is almost finished, and installation is planned the next weeks. And in case of historical buildings, restorers usually are not willing to give permits for intervention that exceeds necessary works. Due to this reason, usually it has to be reduced to minimum. But thanks to vacuum glass, there is no need to replace existing old windows and keeping the same appearance while increasing glass thermal performance and giving possibility of adopting the solutions to this demanding type of buildings. And the third demo pilot objected to EENSULATE retrofitting is San Giovanni Public Library, located in Pesaro in Italy. And it's a historical building renovated in 2000 with many contemporary elements. In this case, the retrofitting includes the EENSULATE wick utilization and replacing the existing double glazing in the wooden door frame, and not affecting the aesthetic of the building. And after installation activities, and currently solutions are under validation process in the phase of monitoring. And in order to investigate performance of WICS model, a building will be monitored in regards of thermal and optical behavior, but also indoor comfort to have comparison between vacuum glass and existing ones. As a summary, main advantages of WIC units, despite of improved performance taking into consideration installation process, are low weight, triple glazing of 30 kilo versus vacuum of 20 kilo with improved parameters. Then thin construction. So it's 12 millimeters versus a 36 millimeter package for triple glazing, which leads to the reduced window and facade profiles construction, and facilitated logistic due to the weight and space necessary during transport and storaging, but also during installation. And also a possibility to improve indoor comfort and thermal performance, also in a retrofitting of such a demanding buildings like historical ones. And for manufacturing of the vacuum glass is used tempered paints, and it is also possible to laminate layers, external paints, which is important for installation in the height due to the safety reason in order to avoid falling risk in case of weak breakage. And also there are possible different configuration and joining with another type of glass in order to improve parameters. And there is also no thermal expansion and contraction in internal chamber. So application, it's not limited by geographical location or elevation. And so we believe that there is a huge market demand for those type of solutions due to its features, also for other applications. But still there is some work to do, mainly with regards of aesthetic aspect and in terms of minimizing perimeteral margin caused by sealant and getter. And another issue is to work on automatization of glass manufacturing process and before introducing to the market. And the further works are foreseen after validating of the system performance through analysis of the monitored results of each demonstration building. Thank you for attention. And now we will present short video made at the first stage of installation, the facade in school in Poland. Thank you very much.
Thank you very much, Anna, for your presentation and for the video. Now it's time for the Q&A. We have received several questions. Thank you very much for your activity. I will read out the question and I would ask the speakers to take them as they deem necessary. So we will start with the general questions. First question, which are the main barriers for project products implementation according to you?
Okay. Here I am. Okay, I can answer. I mean, the main barriers are we can consider the fact that the products are not yet ready to be put into the markets because we are a technology readiness level quite high, but not, I mean, fully in an industrial production phase. And for this reason, we need additional final development for putting them into the market, and also for for spreading them all around Europe first, of course, and then maybe around the world.
Thank you very much, Daniela. Then we have questions which are specific for the VIG. We have a question: could you precise what is the G value of the VIG? Maybe Alessandro would like to answer this question.
Yes. Let's say the target was 0.3, and at this moment the tests we are doing are perfectly in line, probably even better, but let's say that's something that we are working on, so it seems to be also a lot better than the 0.3, so it's a very good product.
And we have another question regarding the VIG, maybe for Alessandro. A 20% improvement is announced for durability, but durability of what? Durability of the U value of the VIG compared to today's double or triple glazing?
Yes, correct. Let's say that it's, the durability is expected to be 20 years for the performance of the U value of the glass.
Thank you very much. And we have a final question. What is the current TRL achieved by the different products, and what is the goal for the end of the project?
Yes, Alessandro, maybe you can give us details about the TRL level of the insulate module as an overall product. I don't know. But I can...
Yes, the TRL of the insulate facade itself after the test is 7. So it will be perfectly, the test will demonstrate the effectiveness of the facade in laboratory environment. And thanks also to the installation on demo side, probably we could consider also almost close to 8. So after the monitoring activities, I think that TRL 8 for the insulate facade model is something achievable.
Yes, thank you, Alessandro. I think that we can consider more or less the same also for the VIG technology. I mean, the panel, because as I said, it is not an industrial product yet, but we tested it in several different laboratories with laboratory tests, but also we are validating it in different demo sites. So the TRL level is high, but again, we are close to put into the market, and I know that the partners are already discussing and make some agreements in order to go ahead with the products development, since they are very, very interesting, also after the end of the project. That is, as I said, fixed by the end of May 2021.
Thank you very much both for answering the questions. If the audience has any further questions, feel free to send them to the presenters. You have seen the contacts, and also you can watch the recorded session on the BUP website. Thank you very much for your attention. Please follow the EENSULATE project till the end. You can follow it on the social media and also on the website when you can see the most recent updates. And we will be very happy to report on the final result of the whole project. Thank you all speakers for your presentation, and have a good afternoon.
Thank you.
Thank you very much.
Thank you very much. Goodbye. Bye-bye.